Okay, welcome to the video on chapter 16. We continue our conversation about probability and then some next steps with probability. Make sure you have your note sheet with you as you go through this video, and there will be times where I will be referring to the examples that I've given you on the note sheet. Okay, so chapter 16. So first of all, we're going to be talking about several different types of variables and how it pertains to statistics. So first of all, a random variable, and we really don't usually see the the letters RV, but I wanted you to see that in case I need to write it that way. So a random variable is a variable that assumes any of several different values as a result of a random event. So a random event occurs, and we denote the capital letter X, make sure it's a capital letter, as that event occurring. So a random variable it has to take on a numerical outcome. So importance here, capital letter X, and that it takes on a numerical outcome. There are two types of random variables. The first one is a discrete random variable. And a discrete random variable is a random variable that takes on a finite number of distinct outcomes. There are a countable number of outcomes, and that's how you know if it's discrete or not. As always, all probabilities must add up to 1. Every probability has to be somewhere between 0 and 1. That is a bit of a review from chapter 14. Usually a probability histogram is created to show the information, or I guess it can be created to show the information. But keep in mind that probabilities are between 0 and 1. So that's for a discrete variable or discrete random variable. It has to have a countable number of outcomes. So for example, flipping a coin and counting the number of heads. That is a discrete random variable. It takes on any integer value, but it can't take on any number in there. You can't flip 1.2 heads. It has to be 1, 2, or 3, or 0 heads that come up. The number of students present in our class on any given day is a discrete random variable because we have an exact number of students that show up that day. Or if I have different colors of marbles in a jar and I choose how many red marbles are in the jar, the number of red marbles, or for that matter, blue marbles or green marbles, are all examples of discrete random variables. A probability model is a chart that displays those possible outcomes, and it will show what the possibility could be and then also what the probability is. So the reason describing big X and little x is in this probability. So you're going to see this often. What's the probability that X equals X? So big X is the random variable, the outcome, and the little x represents each possible outcome. So we're saying what's the probability that the random variable is equal to like that shows up? What's the probability that that shows up is what that is saying. Okay. So first, I want you to turn to your notes, and you should have filled in random variables, discrete variables, and now we're going to be on to these examples right here. Okay. So looking at, it's not really example 3, I just couldn't change it. So looking at this example, put all letters into a hat. If you choose a consonant, I pay you $1. I'm not really paying you $1. And if you choose a vowel, I pay you $5. And X is the random variable representing the outcome of the experiment, and create the distribution. So this is making a probability model because we're going to show what that looks like. So we'll just make a very simple table. Didn't quite make it long enough. Okay. And in this table, I'm going to have the values of X, so the values of the random variable. This is a capital letter X. And then underneath it, I'm going to have the probability that X equals X. Okay, so what are our choices? I guess I did make it long enough. What are our choices? That you receive that the outcome is $1 or the outcome is $5. Okay. So if there are so many consonants, put all the letters of the alphabet in a hat, and I will pay you $1 if you choose a vowel. Well, how many vowels are there? Out of if you choose a consonant, I'm sorry, I read that wrong. If you choose a consonant, I pay you $1. So there are 21 out of 26 consonants. And then the others are vowels. That is a probability distribution model. So it's just what are the outcomes and then what are the probabilities. Okay, so let's do this one. College instructor is teaching a large class, traditionally gives 10% A's, 20% B's, 45% C's, 15% D's, and 10% F's. If a student is chosen at random from this class, the student's grade is on a 4-point scale. And that's a random variable because we're only doing 0, 1, 2, 3, or 4 and create a distribution. Okay, so these are my x's. This is the probability that it's going to happen. Oops, that's an equals. So capital letter X equals a little letter x. So, and my options are getting a 4, 3, 2, 1, or 0. So these are just the percentages that we were given. 10% of the students get an A, 20% get a B, 45% get a C, 15% get a D, and 10% get an F. Okay. All right, so what's the probability that a student has a grade point of 3 or better? So we start at 3 and we include 3 because it says of 3 or better, and we add the probabilities of getting a 3 or better together. So the probability that the person's going to get a 3 or better is 0.3. Probability that a student has a grade point of 2 or worse, so we're going to add 2, the probability that getting a 2 plus the probability of getting a 1 plus the probability of getting a 0 together, and we have 0.7. Okay. All right, so a probability model, and you'll see this with discrete. We're going to spend most of the time talking about discrete variables. Okay, and in this histogram, we have the grades at the bottom, 0, 1, 2, 3, 4, or 5. 0, 1, 2, 3, 4, that's what I meant. And then on the side, the relative percentage of grades. So this is a picture of the probability model that was drawn above. Okay. All right. Oops. Okay, so we did that notes. Okay, the second type of random variable is a continuous random variable. And a continuous random variable, it takes on any numeric value within a range of values. Okay, so it can be infinite or bounded either at both ends. So what that means is it doesn't have to be bounded, but so it can be at either or both ends of the range of data that you're given. Okay, the probability distribution is going to be a density curve, so it could often be a normal model. You'll see it described that way. It could be skewed one way or the direction or the other, but it's typically going to be that type of a curve. We can't put it as a histogram necessarily. It will be more rounded than that because we have so many different variables, so many different values in there. All right, so the probability that x is between an interval of numbers is the area under the density curve. Okay, and we are going to be reviewing z-scores, the percentiles, how many percent of students are below a certain percentile, the 95%, etc. Okay, so this is something that we will spend time next week reviewing about this. So probability, remember, or probability that a continuous random variable is exactly equal to a number 0, or to a number is 0. It's not going to be exactly a number. Okay, it's not going. It's a value that is going to be around a range, but it's not going to be exactly on one number. So an example would be the heights of the students in the class. The time it takes to get to school, it's going to change. The distance traveled between classes, you could take a different route. It's going to be a little bit different every single time you do it. So that's how we define a continuous random variable. Okay, so from those random variables, we're now going to talk, so that's just two different types. Now we're going to talk about what we do with that. And the more of the information that we do with that is we're looking for the mean of a random variable. We've talked about mean a lot and how much we use that information to determine where the data lie, what's going to be happening. Okay, so the mean of a random variable is known as the expected value. So we're going to spend quite a bit of time talking about the expected value. Okay, so the mean of a discrete random variable x is its weighted average. Each value of x is weighted by its probability. Maybe it's more likely, or with this college professor, it's more likely to get one grade than another. So we can't say they're not equal weights. Okay, but we want to know, what is our outcome going to be? Well, more students are likely to get one grade over another. Those probabilities are not exactly the same, and we want to know what is the weighted average going to be with this. So in order to find the mean, we multiply each value of x by its probability, and then we add them all together. I'll show you the formula in just a few slides. So over the long run, that expected value doesn't really mean that we definitely know that that's what's going to be, right? We don't know, we don't expect one observation of x to be close to the expected value, but over the long run, after lots of observations, that's what we expect the average to be. So again, the law of large numbers is that over and over and over, it will start to even out as to it'll be closer to what the real value is. Okay, so here's what the expected value looks like. Mu is the mean of the population. So this is mu x. And sometimes you'll see it written this way as E of x. And it's equal to the sum of all of each x multiplied by its probability. So we're going to go back to the note sheet. So I have two examples here. So a fair coin is flipped 3 times. Find the mean of the discrete random variable that counts the number of heads. Well, first we need to figure out what is the probability of flipping a head. So I flip a coin. We're going to make a small tree diagram. I flip a coin and I get either heads or tails. I'm going to flip it 3 times, and each time I can get heads or tails. There's a cookie jar problem on your homework that is similar to this one. Heads or tails, heads or tails, heads or tails, heads or tails. Okay, so there are going to be 8 possibilities of what can happen when I flip this coin 3 times. So we want to find the mean of the discrete variable. Well, first we have to make our distribution or our probability plot. So I have x. I'm going to make this a little bit shortcut. The probability of x. So we can get 3 heads, 2, 1, or 0 heads. The probability that I get 3 heads is 1 out of 8. You just count up the h's. So there's only one way that I can get 3 out of 8. The probability of getting 2 out of 8 is 3 out of 8. Okay, this is all the number of heads because that's what the problem is asking for. I get 1, it's 3 out of 8. And getting 0 is 1 out of 8. So I'm just counting up. Okay, here's the time I don't get any. Okay, I get 3 out of 8 by having heads, tails, 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 head, etc. Okay, so 3 out of 8 times I can get 1, and 3 out of 8 times I can get 2. Okay, so to find the mean, I have, so mu of x is equal to the probability of each, or is equal to the outcome that I am looking at, times the probability, plus 2 times 3 over 8, plus 2 times 3 over 8, plus, oh, that should be a 1. 1 times 3 over 8 plus 0 times 3 over 8. 1 out of 8. Okay. 1 times 3/8 plus 0 times 1/8. Okay, when I multiply it all out and I add it all together, I get that mu of x is equal to 1.5. We're going to be using this later. And this is a small letter x. It's u and then a sub x. Okay, now we do a different one. The daily lottery costs $1 to play. You pick a 3-digit number. If you win $500. Find the expected value of the lottery. So what do we expect the value of that lottery ticket to be? Knowing that we're going to pay $1 to play, okay, what do we expect to win when we do this? We're not necessarily going to win that, but what do we expect to win? Okay, so I make my chart. My possible outcome, my random variable, I only have 2 choices. I have that I'm going to win $500 or I'm going to win $0. The probability that I'm going to win $500 is 1,000. I have 10 times 10 times 10 because I have the numbers 0 through 9. There are 10 of them. So I have 1 out of 10 for the first digit, 1 out of 10 for the second digit, and 1 out of 10 for the third digit, because I could have the number 111, for example. Okay, so the probability here is 1 over 1,000. And then the probability that I don't win anything is the complement of that. So 999 out of 1,000. Okay, so to find the expected value, I have 500, that's my outcome, times 1 over 1,000 plus 0 times 999 over 1,000. Okay, so when I solve for this, I get 0.5. Well, I want the expected value, so what do I actually expect to win at the end? Well, I expect to win 50 cents, but I've spent $1 on this. So my actual expected value in this is negative 50 cents. That's what I expect if I win. Okay. All right, so let's just fill in this. So as the number of observations increases, the mean of the observed values because the x bar is just the observed values, approaches the mean of the population. Doesn't quite fit on this line. And mu, so I need you to make sure that you're writing down the correct letters. This mu is the population, whereas x bar is just for the observed values. That's the sample. Okay, so the more variability, in the outcomes, the more trials are needed to ensure that x bar is close to mu. So if there is a very wide variety, I need lots and lots and lots and lots of trials so that x bar becomes closer to mu, so that those observed values get closer and closer to what the population is actually going to be. Okay. All right, so the expected value, the examples. Okay, so here are some rules for the means. Okay, so if x is a random variable and a and b are fixed numbers, then mu, and we write it this way, sub a plus b of x, bx, is equal to a plus bu x, sub x. This is just something you need to memorize. So and the examples will help make this a little bit more obvious, okay? All right, if x and y are random variables, then u x plus y is equal to u sub x plus mu sub y. Okay, so the only difference here is if a is a constant, we can just add the constant plus whatever b is times the mean. Okay, all right, so now we're going to go back to the notes. Let's see an example. Okay, so for example 10, You play 2 casino games. Game 1 has an expectation of losing $1 a game, and game 2 has an expectation of losing $2 a game. If you play both games, what is your expectation for both games? So again, there's that word, expectation. So that's telling you we're going to use the, we're going to find the mean for what that expected value is. Okay, so using the notation, I think is the best way to see this. So u sub x plus y is going to equal, and we have an expectation of losing $1 a game, and game 2 has an expectation of losing $2 a play. So we're already given the expected values for them separately. So what would the expected values for them be together? So because of the formula, we can say that we can just add them together. So we have -1 minus 2 is equal to -3. Okay, so the expectation for both games is that I'm going to lose $3. Now you might think, well, that seemed pretty obvious, but the problems get a little bit more complicated. So you need to decide, well, okay, is it really okay that we can just add the expected values together? And in this case, yes, it is. Okay. All right, so the second example, you go to a casino and play the same slot machine, which averages losing 15 cents per day. Okay, you play the machine 100 times and then leave, and you pay $5 for parking. Okay, so the constant value is the $5 for parking, because that does not depend on, or that doesn't change with how long you're there or how many slot machines you're using. What is changing is the 15 cents a play. I think I said a day. I meant a play. Okay, so mu of, and here's my 100x minus 5, where x is the 15 cents every time you play the game. So my expected loss is 100 times the 15 cents a play minus $5 that I paid for parking. So that is equal to 20. I end up losing $20, or that's what my expected loss is for being at that game. Okay, back to the PowerPoint. Okay, so 2 more concepts we're going to talk about with the random variable. That is variance and standard deviation. We touched upon variance a little bit way long ago, and we spent a lot of time talking about standard deviation. Okay, so remember that the mean is a measure of center, and the data also require a measure of the variability, or how much this data is being spread out. So how much does it vary, and how much is it spread around the mean? So variance, this is the symbol that we use, variance squared, and the standard deviation is the square root of variance. So I don't think you may not remember that from a while ago. So here are just formulas, and I will give you a formula sheet. You need to write this in your notes, and probably at the end of this unit I will give a formula sheet, and when you're taking a quiz I will write this on the board. But as you do your homework, you need to have this in front of you. Okay, so to find the variance, sometimes you'll see it written this way. To find the variance, it's the sum of the differences between every x value and what the mean is, what the expected mean is. And we square that, and it's times the probability. Okay, so first we find the variance, and then when we take the square root, we get the standard deviation. Okay, so it's just a matter of the formula. So it's the sum, remember this means add, each value minus the expected mean squared times the probability. Okay, so an example in your notes. Okay, back to our fair coin that is flipped. Okay, information from before. So to find the it's asking for the standard deviation. So to find the standard deviation, it's equal to the square root of 3, because remember it was getting 3, 2, 1, 0, or 0 heads. Okay, so 3 minus 1.5. The 1.5 was the expected value that we found earlier in your notes, and 1/8 was that probability. 2 minus 1.5 squared times 3/8. 1 minus 1.5 squared times 3/8. And then to that we add 0 minus 1.5 squared times 1/8. Okay, and we take the square root of all of that, you get 0.866. So that is the standard deviation. Okay. All right, so sometimes it's kind of nice just to be able to plug this into a formula and go with all the work we've been doing. Okay, so again, finding the standard deviation for this lottery game that we talked about. Okay, sometimes you need the variance, so I'm just going to write this as the variance so we get the idea of both. So remember, we had $500 and the expected value was 0.5. My expected value ended up being losing 50 cents. But okay, so it's 0.5 was the expected value times 1,000. Whoops. Plus 0 minus 0.5 squared 999 over 1,000. Okay. You should be doing this on your calculator as well. Maybe pause the video so you see where it comes from. Okay. And this equals, I forgot to write that, 249.75. The standard deviation is the square root of that. So it's the square root of 249.75, which equals 15.803. 15, that's a decimal point in there, 15.803. Okay. Okay. Okay, back to the PowerPoint. Okay, so the median of a random variable, the median is always where 50% of the data is above it and 50% is below it. So when we're talking about a random variable, we know that it's one possible outcome. It's got 50% probability at or above it and 50% at or below that. Okay, it's the value of x that makes that probability greater than or equal to 0.5. The median has a total probability of 0.5 or greater, above, and below or equal to. Okay, so I don't have any examples with median. We will talk more about that as it comes up. Okay, 2 rules for variance. So we had the rules for mean. Now let's look at the rules for variance and how this applies. Okay, so it's very similar to what we just talked about with the mean, but they are a little bit different, and we need to talk about that. Okay. Okay, so the standard deviation or the variance of A plus B, when A and B are fixed numbers, we can just say that that's equal to B squared times the variance squared. Okay, so that's how you solve that if we have that value. If x and y are independent random variables, then what we do is we square the variance. Okay, so we have to work with variances and then change them to standard deviation. We can't add standard deviations. And then you also, you add the variances no matter what. Okay, so if you remember, when we talked about standard deviation, you can't just add a number to have it move. So we have to deal with variances and then change it to be standard deviation in order to get that, in order to see how that works. Okay. Okay, last few examples. Okay, so suppose, again, make sure you read this note. Difference between x and y, we're still adding them. That doesn't matter. Okay, so suppose this equation, y equals 20 plus 10x, converts a PSAT math score into an SAT math score y. Suppose the standard deviation for PSAT is 1.5. What is the standard deviation for SAT math scores? Okay, so here's how we're going to adjust this. So we know that here's my standard deviation. or the variance, of 20 plus 10x, and that's just the formula that's here. And that is going to be equal to 10 squared, that's the b value, squared, because it's b squared, times my variance. My variance was 1.5. So that's going to be equal to 225. So that, oops, 225. Okay, but the question asked for the standard deviation. So to find the standard deviation of 20 plus 10x, I just take the square root of 225. So the standard deviation is equal to 15. Okay, so that's how that changes. So the standard deviation for the SAT math score is 15. Okay, so suppose the standard deviation for the SAT math score is 150 points and the standard deviation for SAT verbal score is 160 points. What is the standard deviation for the combined SAT score? Okay, so the asterisk here is these scores are probably not independent, but we're going to, for the sake of the problem, say that they are actually independent, just so we can, it gives you a visual of how to do the problem. Okay, so I have my standard deviation of m plus v. Okay, and I'm just going to set off right now saying that that's going to be equal to the square root, because really I have to have these in variances. So it's going to be the variance of the math plus the variance of the verbal scores, and the square root of those is going to give me what the standard deviation is for the combined SAT score. So it's equal to 150 squared plus 165 squared, the square root of that, so it equals 222.99. Okay. All right, and that is the end of the video. That is the end of the examples. You're now going to take this information and apply it to the Chapter 16, number 1 sheet that I gave you in class today, and it's also going to be, well, no, I'm not going to post on Classroom. It's also, yeah, you have that. Okay? Let me know if you have any questions.